a spring. It's connecting two particles which are bouncing around, and yeah, that's actually pretty much it. It's just two particles affected by gravity. They're bouncing around. They're connected with a spring. That's it. Boom. So I built this just quickly for Dan from the coding train, who's currently recording a series of videos on physics and code and stuff like that. So yeah, I made this, which is literally just two particles connected with a spring. It's actually quite chaotic, though. You can't really predict it.
So it's a good visualization of a chaotic system?
I don't really know. Because eventually it falls down into just a predictable pattern.
Oh, so once you refresh, it's very chaotic, and then it's more and more predictable.
Yeah. So that's what it is. So I just have a few functions for all the forces. I ended up not using the damping one, but yeah. And then I just have a particle, and it can render itself. It can update itself. It can bounce off of things. Yeah, that's pretty much all there is to it. I then just apply the various forces. I apply the gravity force, and then I apply the spring force.
And why did you call it molecule?
So this website called My Physics Lab has such a simulation, and it calls it a molecule. There are other variations on it, by the way, where you have more than two particles, which are all connected by springs.
So you can also view this as two atoms.
Yeah.
But I guess they never bounce this way.
Yeah. In fact, I think I can do that just quickly. Hang on. Let's just... I'm gonna just duplicate this for a second. Molecule more than two atoms. Particles, and I'm gonna have const, which is the total. I'm gonna call that I don't know, let's just do 3 for a sec. Actually, let's do 2 because that's the thing that I have already. I'm gonna do 4, and then total times. I want to add a particle to our particles list. Like that. And where do I want to put them? Good question, actually. Let's just have center x and a center y. Center x equals 4 divided by 2. Center y equals 8 divided by 2 minus... divided by 4, right? That was my thing. Also have a radius at which they will spawn, which is going to be, I don't know... I had it at 30... Actually, no, I didn't have it at 30. What's 30 times the square root of 2? Around 42. So I'm going to make the R be 42. I'm going to have the x be r times cosine. Okay, hang on. So I'm going to have the angle, which is, okay, I goes from 0 to total. So I go from 0 to 2 pi. Cosine of the angle. Center x. Y equals r times sine of the angle. plus the center y. Gonna make a particle and set its let's just do P is going to be a single particle. It's going to spawn at this particular xy coordinate. We're going to do P dot vel. Do I want to set its velocity? I don't think so. Let's just have it be 0, 0. Particles push P. And then let's not apply the forces for now. So I'm just gonna, So I'm just gonna show what this is gonna look like. Comment it. I'm also gonna comment the spring out. And then for every particle, I want to check it against the edges and update it. And also for every particle, I want to render it. So now, I still have two. Okay. Oh, but that makes sense because I have two particles. Okay. So I have 3 particles now. So you can see here's that. So now I'm gonna just go through every particle and apply its force. So I'm gonna do apply force, gravity force. Hang on, what was its strength? 0.2. Apply force, gravity force, 0.2. So what this is going to do is it's going to make them fall down like that. But I have to connect them with a spring. Okay, this is going to be a bit difficult here. How do I do this? I'm pretty sure what I want to do is go through every particle that's not this one. So I'm going to go through 4 times other of particles. If P is not other, because I don't want to connect it to itself, that would be ridiculous. I'm gonna do P dot apply force, spring force, P other, and what was its length? 150 and 0.01. So let's do this. So now it's going to apply the spring force. So you can see they're springing around. I do need to connect them though. So I have to do the same loop here. Actually, let's do for let I equals 0 and less than particle start length I plus plus. I'm going to do everyone after it. So I'm going to do j equals I plus 1. J is less than particles at length j plus plus. And then I'm going to do line. And then I'm going to do the same thing that I did here. So this is just going to go through every pair of particles and draw a line through them. I have to do particles index I. Index j. So now,
Woohoo!
So now I have more than 3 particles. And let's actually take the alpha out. So let's just comment that out. So now you can see I have more than two particles that are connected with a spring. I can do more, so let's do 4. I don't know. I don't know what makes sense. Let's do 5. And 6 looks like this. Whoa. I think at this point it just makes sense to take the gravity out. So let's comment this out. Wow.
In space. Whoa! Did you see that? It just flew off in space.
Let's put it back at a more reasonable thing. Like, I don't know. What should we do? Let's do 4.
Yeah.
4 particles was good
It was fun, and you could still observe it.
Yeah. Okay, so that was fun.
Are you gonna say anything about the trig?
This doesn't use any trig.
Oh, this one doesn't use any trig.
Well, except for where I set the particles up, but that's, yeah. Oh, wow, it got completely off.
Yeah, because I think you should have gravity on. Or do you have it on?
I have it on!
Oh, just because it's so springy, right?
Yeah. Still, it looks like just a giant little, like, squad, which is, like, right.
Is there, like, more elasticity? The more balls there are? The more particles there are? They can jump higher? But it also...
Well, the more particles there are, the more springs there are, and the more force there is. So, yeah. Oh, wow. Yeah, at this point it just goes off there.
I wish I had something like this in real life.
Let's make the height be a bit more. Just small of it. Start timing it. I think it makes more sense to start on the There we go. Change the spring length to be less. Okay, let's make the spring length more like 100. Just like that. So it's less springy. Well, it is just as springy, but the springs are just shorter. So yeah. There's no way around it bouncing like that.
It was more fun the way it used to be. Stayed on canvas. Simon's jumping next to me, repeating these movements.
Well, do I really have like 4 things that can move? I don't know.
4 limbs.
I mean,
You do?
yeah, that's accurate.